Okay, so today we are going to work some more with this Algebra Standard 5.0. We're going to solve multi-step problems involving linear equations and in one variable. And an example of the type of problem we're talking about here would be something like this. Here is a linear equation, and there's only one variable, just like it says right here, one variable, and we're going to need to solve this equation so that we know what x equals. Now, the objective today is that I want you to look for and make use of structure as we solve multi-step equations. So let me talk a little bit about what does it mean to look for and make use of structure. If you look at this building here, if we're standing up real close to this building, let's say we are standing in front of this entrance right here, we may only see the door to the building. We may only see maybe a window next to it, or we might see the doorknob on the door, people coming out of that door, but we're not seeing the entire building. If we're standing on top of this roof, if there's a way to get up there, we may be looking at this flagpole, and that's all that we would see. Or maybe just this this part of the building right here, and that's all that we would see. But it's one thing to look at a small detail of an entire building, and it's another thing to step back, way back here, and take a look at that building from afar and notice the structure, the total structure of that building. When you step back and look at that building, just like the way this picture was taken, what you'll notice is there are many, many, many different floors to this building. You'll also notice that this floor is a little bit different than all the other floors, and so is this one. It might have a very high ceiling on both of these floors, but then you see all of these floors look like they're the same height, and they all have the same number of windows, and they also, you notice there's basically a bend here and here, so that there's another side of the building on each side here. You'll see the structure, the total structure of the building differently when you step back and take a look at it than you do when you're right up close. Now, in our work today, I'm going to want you to do the same kind of thinking that this photographer had when they stood back and took a picture of the entire building when you are looking at the entire equation that I'm having you solve. I don't want you to look at the fine details of 5, then the equal sign, then there's a 10, then there's parentheses, and then there's an x and a 1. I want you to instead step back and look at this equation as a whole and notice the structure. So let me show you an example of what I'm talking about with this problem. So we have 3 times the quantity x minus 1 equals 0. So the first thing I can do when I'm noticing the structure of this equation is I can notice that here I have 3 times this whole quantity. So basically I have, and I'm going to give these different variables. Let's say I have p times q. Okay, and p is what 3 is, and q is what x minus 1 is, equals 0. So I know that I have some number here, some quantity here, times some quantity here, equals 0. P times q equals 0. It's a lot simpler to look at this problem that way. Now, in order for these two quantities to equal 0 when they're multiplied together, one of the quantities must be 0. So I'm going to backtrack my green marks here. And I know that 3 is not 0, so x minus 1 must be 0. It has to be. In order for 3 times something to equal 0, then this x minus 1 must equal 0. So right now, I can see right away that this x minus 1 has to equal 0. What must x be in order for the entire quantity to be 0? It's going to have to be 1. There's no other number it can be. 1 minus 1 equals 0. 2 minus 1 equals 1. Doesn't equal 0. So it's going to have to be, it has to be 1. So what I want you to notice that I did is that I basically stepped back and I looked at this whole entire equation and reasoned through the structure of the equation to figure out what x must be. I did not use our number properties. I could have. There's other ways I could have solved this problem. But instead, what I'm particularly wanting you to work on today is how we look for and then make use of structure to be able to solve multi-step equations. And so, just to recap, I thought of this as one quantity. I thought of this as another quantity. And I looked at the structure of this problem. It's telling me that 3 times this quantity equals 0. That tells me this quantity must be 0. And if I think about what would make this quantity equal 0, it would have to be 1 minus 1 equals 0. So that tells me x equals 1. And notice that I didn't really have to write a whole lot to be able to reason through that. But I do want you to at least be talking out your reasoning and writing out what you can, just so that to help you be clear and precise with your language. All right, so now you saw me do one, so I'd like for you to work with me through this one. So we have 6 equals, if everyone can read this with me, 6 equals 2 times the quantity x minus 3. All right, so first thing we must do is think about the structure of this equation. What we see is 6 equals all of this entire amount. This whole amount here has to equal 6. Okay? Now the next thing we can do is we can think about what on this side of the equation, where do we see 2 quantities multiplied to each other. So see if you can talk about that with your partner and find 2 quantities that are multiplying to each other. Alright, so what we see is 6 equals 2 times the quantity x minus 3. So we know that 2 times some number must equal 6. There's only one number that equals 6, and that would be 3. So that tells us that this x minus 3 must equal 3. There's only one way that x minus 3 can equal 3. I want you to figure out what x must be. Alright, so x 6 minus 3 equals 3. So that tells us that x must equal 6. Okay, so I want you to practice talking through that reasoning with your partner real quickly, just to review what we just did with this problem. Alright, so now let's look at this third problem. You saw me do one, we worked on one together. I want you to work on this one with your partner. Yes, there's a slight difference with this problem than the other 2 problems. If you look at them, we have whole numbers times a quantity in the parentheses. Here we have a whole number times a quantity in the parentheses. And here we have a fraction times a quantity in the parentheses. But I did this on purpose because I want you to think about the structure of the problem. The fact that you have a fraction here shouldn't really matter. You should just be thinking about the structure of the problem. So see if you can work with your partner and first of all, step back and say what this problem means to you by reading the problem and finding 2 quantities that are being multiplied to each other to equal another quantity. Okay, I'm going to walk around, I'm going to check your work, and I would like for you to be reasoning through to see if you can find out what x equals. Alright, so what I saw many of you do was you saw that 1/2 is a quantity, and you saw that x plus 4 is a quantity. So basically what that's telling us is that 1/2 times this other quantity equals 2. What must this quantity equal in order for us to have 2 on this side? If we multiply this quantity by 1/2, it can only be 4. So, in order for x plus, I'll put that in a different color, x plus 4 to equal 4, x would have to equal 0. There's nothing else that would allow us to have 4 there. And if I substitute it in to this original equation here, if I do 1/2 times 0 plus 4 equals 2, you'll see that I have 1/2 times 4, because 0 plus 4 is 4, And then I have 1/2 times 4, which does get me 2. Okay, so here's 4 more problems that you can practice with, and I would like for you to work on this with your partner. And first of all, it's very helpful to read through the problem orally, just to be able to hear yourself say what's the meaning of the problem here, what's the meaning of the equation, what's it really telling you about the values. Find, I want you always in every case, because I gave you these kinds of problems where you will always have 2 quantities being multiplied to each other. So I want you to look for those 2 quantities being multiplied to each other to help you see the structure of the problem and then reason through what x must equal.